Welcome back, dear students. In the last session we completed exercise 7.2. In today's session we are going to start a new exercise, that is exercise 7.3. So there are 5 questions in this exercise. Exercise 7.4 is deleted from your syllabus, okay, so you can skip this exercise. We are not going to do exercise 7.4, and even the optional exercise, that is exercise 7.5, this is always deleted, okay. This is just for your knowledge. So exercise 7.4 is deleted this year, and exercise 7.5 is optional, no need to do that. So this will be the last exercise of this chapter, triangles. You might be thinking that this is a very difficult chapter, but believe me, it's not difficult at all if you practice it regularly. Students, those who are practicing it regularly are able to do this chapter very easily. So practice regularly before you forget it, okay. So in this exercise 7.3, question number 1 you have to try on your own, okay. For your reference, I have simplified the question, okay. Everything is simplified. I even gave you all the solutions. So why I'm asking you to simplify, because I explained you all the rules and we applied those all the congruency rules in the first exercise. We did 7.1, we also did 7.2. so you have got enough practice of congruency rules. So you have to use suitable congruency rules and solve question number 1. So try it. If you get any doubt, you can refer the solutions which I have given, okay. So I'll continue with question number 2 today in this session. So let's go for question number 2 of this exercise. So it's given that AD is an altitude of an isosceles triangle ABC. What is AD here? AD is an altitude. What do you mean by altitude? Altitude is nothing but height. So AD is perpendicular. Height is always perpendicular to the base here. So AD is altitude and it should be perpendicular, in which AB is equals to AC, okay. So AD is an altitude of an isosceles triangle in which AB is equals to AC. We need to prove that AD bisects BC. So we have to prove that this AD cuts BC into 2 equal parts, okay. So we need to prove BO is equals to BD is equals to DC, okay. Bisects means dividing it into 2 equal parts. So we need to prove BD is equals to DC, and AD bisects angle A also. So we need to prove this angle is equals to this angle, okay. So in an isosceles triangle, this altitude will always bisect the base as well as the angle, okay. This is the property of an isosceles triangle. So we'll prove this first, then we can use it whenever required, okay. So how to prove? What's given to us, we'll write first. Given is triangle ABC, okay, isosceles triangle, and AB is equals to AC. AD is the altitude, so ADC is will be equal to ADB, that will be equals to 90 degrees, okay. So what we need to prove here, let's write that also here, okay. We have to prove BD is equals to DC and this angle is equals to this angle, BAD is equals to CAD, okay. This is your RTP required to prove. How to prove? Which rule we can use? Which congruency rule we can use here? You can clearly see here in this 2 triangles, triangle number 1 and 2, these 2 triangles, we'll see what are the congruent parts. I can say this angle is equals to this angle because both are 90. Then I can say AB is equals to AC, okay, right angle, then that is hypotenuse. Then which other part I can take here, because I need 3 parts. How many parts I need for to prove 2 triangles are congruent? 3 parts. So I got 2 parts till now, 1 angle and 1 hypotenuse. Then what is the third part I can use? Yes, I can use this part also, okay, common part. So I can say these two triangles are congruent. Okay, once they become congruent, I can say by CPCT I can say this. So let's continue with the steps now, how to write the steps. Okay, in triangle ADB and ADC, we can say ADC is equals to ADB is equals to 90 degrees. Okay, then AB is equals to AC, just now I said you, and AD is equals to AD, that is common. So these two triangles are congruent by RHS, right hypotenuse side. Okay, RHS congruency rule. So once they become congruent, the remaining parts will be equal automatically. They are called CPCT, you know that very well. Corresponding parts of congruent triangle. So I can say BD is equals to DC by CPCT, and BAD is equals to DAC. Okay, we can say BAD, not BAC. Okay, we can also say that BAD angle BAD is equals to angle CAD. So finally it is proved that this altitude bisects the angle as well as the base, that is BC.